Good afternoon. In a subject of engineering thermodynamics, today we are going to see a boiler heat balance sheet. How to draw a heat balance sheet for boiler. Okay. Heat balance sheet can be drawn for IC engine or other power generating equipment devices, but today we only focus on boiler heat balance sheet. So as the name suggests, it is nothing but a balance sheet which is giving a information about heat. So as in general, we know that what is balance sheet. So balance sheet is how much is the input and how much is the utilization of that input. So that kind of work we have to complete regarding heat for boiler. So let's start today's lecture. So first of all, we will see what is the configuration of that boiler plant, how the heat generated, where it is used. So imagine this is a schematic of a complete boiler plant, and this is boiler shell where we are generating a steam, and in boiler shell we supply a feed water, and there is a blower to supply combustion air. So imagine we are using suppose coal. So coal itself will not burn unless we provide a oxygen in terms of air. So there is supply of air. So for that we are providing one blower. This blower will forcefully supply air as well as it will uh, assist all the flue gases to acquire a certain path. Otherwise, all flue gases will accumulated in this chamber only, and there will be no output path. So this high pressure supplied air will use to burn the fuel as well as to assist the flue gases, hot gases to acquire certain path through which it will move ahead and exhaust it into the atmosphere. So when we run this blower, so definitely it will suck air and blow at certain high pressure. This is called the economizer. Economizer, that means in a boiler plant we never supplied feed water directly into the boiler. Why? Because each time if we are going to supply a boiler from our fresh storage, and normally it is at room temperature, so what happened, we have to heat up or we have to supply heat to that particular water from rising its temperature from room temperature to its boiling point. Suppose room temperature is 30 degree, so we have to supply heat to that water to first rise its temperature up to 100. So 30 to 100, it is just acquiring that is we can say a sensible heat, due to which its temperature gets changed. After 100, whatever be the heat supplied is there, it is utilized to generate a steam. Now imagine, suppose I am not using room water, I am using preheated water. So preheated water, suppose it is at 50 degrees centigrade. Now I already preheat that water and then I supplied it to boiler. In initial case, I have to supply heat. So room water temperature 30 to 100 rise should be there. Now preheated water, if I supplied, suppose preheated water is at 50 degrees centigrade. Now I have to supply little, that means less amount of it, because already water is at 50 degrees centigrade. Now I have to supply only to rise its temperature up to 100. So 50 to 100 temperature difference, I have to supply that much amount of heat. So our total amount of heat is reduced. For that, we have an economizer. So economizer, it states that it economizes whole steam generation process. That means it's save the cost. So it economize all the heat supplied process by recovering waste heat. Then after there is another device that is called air preheater. It is also a heat recovery device. Imagine, suppose humid air is there. Rainy season, we know that it is a humid air. So when humid air is supplied to burn some sort of coal, so what happened during burning? Some amount of heat is already utilized first by air. So air moisture will vaporize first, then your air become dry, and then that dry air actually take part in combustion. So before your air come and take part in combustion, we have to preheat that air so its moisture content get vaporized. Otherwise, moisture, that means droplets of water, that kind of mist of air, it will not useful to burn the coal in that much efficiency. Otherwise, the coal will burn, but it will not produce that much amount of heat. So in short, whenever we supply wet air, the air which having a moisture, burning heat, some part get utilized by air itself to vaporize its moisture contents. So that means we are not completely using heat to boil the water. Some part we uses to vaporize the water vapors from air. So that we use a air preheater. So what is the use of air preheater? We take atmospheric air, it might be a wet air, and it get heated in air preheater. So when it get heated, so its moisture content reduces, its temperature little bit increase, and it will promote combustion when it come in contact with a coal. So for that we use a preheater. And then of course in last, chimney, because we have to exhaust whatever be the exhaust gases into the atmosphere, but above certain level of height. We can't escape it is at a ground level, just like our vehicle having a silencer which is nearby the ground. But for industry or boiler plant, we can't exhaust all the emission nearby the ground. We have to build one chimney up to certain height, and then after we have to exhaust it all exhaust gas into the atmosphere. So our bottom level atmosphere remain unaffected by this pollutant. So we have to use the chimneys. Second, when we are talking about a natural draft, then also the chimney is working a lot. So when we will go in detail, that time we will check out what is a natural draft and what is the artificial draft. Okay. Right now, for the basic information, there is one boiler plant which having a boiler where we are supply feed water after preheating. That preheating take place in economizer. Whatever be the coal is there, that coal burning take place due to the preheated air, and that preheating of air is used by a air preheater, and then the last exhausted gases will exhausted into atmosphere through chimney only. Now suppose there are supplied of coal in a boiler furnace, and we supply that preheated air. Now air come in a contact, it provide oxygen, and your coal get burned. Hot exhaust gases are evolved. Hot flue gases are evolved. That hot flue gases supply heat to boiler, and remaining hot flue gases travel ahead, and after boiler shell, it travel through first economizer. That means whatever with the exhaust gases in a furnace, after delivering some amount of heat to the boiler water, remaining amount of heat carried by that exhaust gas, and that exhaust gases enter to the economizer. Now, during passing through the economizer, hot gases are flow over the water tubes. So whatever be the room water storage is there, we are supplying room water to the economizer, and when that water flow through this economizer, so hot gases utilize its heat to preheat the water. So no doubt hot gases loses some heat and your feed water get preheated, and that preheated water we supply to boiler. So in boiler itself we require a less amount of heat to generate steam. There is another advantage. If we are not using economizer, then whatever be the amount of heat supplied to the boiler, then after that heat carried by exhaust gases, that all heat get wasted because it is not utilized for heat steam generation. But by using economizer, we recover that waste heat to preheat the water, and if water get preheated, so definitely steam generation requirement of heat will reduce. That means we economize all the system. So first, whatever be the hot gases evolved in furnace, they deliver some heat to boiler. Remaining heat carried by these exhaust gases, these remaining heat exhaust gases, some part of heat again delivered to the economizer water, where water get preheated. Now, no doubt, exhaust gases will not be reach to atmospheric temperature. So exhaust gases still having some temperature. These exhaust gases then pass through air preheater. Now when it pass through air preheater tubes, so with the help of one blower, air is enter into the air preheater. It will flow over these hot fire tubes and get preheated. That means its moisture get reduced, its temperature increases, so it promote the combustion. So again in air preheater, these hot exhaust gases deliver some heat to preheat our atmospheric air. Now ultimately whatever be the heat remaining in exhaust gases, those exhaust gases are allowed to pass through chimney, and at a particular height these exhaust gases are exhausted into the atmosphere. Ultimately, we know in a very general way, that is there are three kind of pollutions, that is soil pollution, air pollution, water pollution, correct? Even though we can say noise pollution, but along with this there is a one serious factor, that is a thermal pollution. Now imagine, suppose we are not using a economizer and air preheater, we directly use the chimney. So what happens, suppose 40% heat is utilized in generation of steam. So whatever be the heat generated during combustion of fuel, so 40% is utilized by boiler itself. Remaining 60% heat is wasted, and that 60% heat is going into the atmosphere. That means thermal emission will be there. Now whatever be the 60% heat having that exhaust gases after boiler, suppose 20% is used by economizer, suppose 30% used by air preheater, so only 10% heat is actually enter into the atmosphere. That means thermal emission get reduced. So by using economizer, air preheater, we recover waste heat. No doubt there is another one device that is called superheater, steam superheater. That superheater steam is actually lie in this zone. So it will take a steam from boiler, and your steam piping will be in combustion chamber, and then it will be allowed to move out. So all these things, superheater, economizer and air preheater, all these are waste heat recovery devices. These are called as accessories. Without all these devices, your boiler can run, but its efficiency will not be there. When we use all these accessories, so your boiler having a higher efficiency. And no doubt, we recover waste heat, so thermal emission will be less. So this kind of arrangement is there. I think idea is clear that how the boiler plant is working. So in boiler plant, we use a preheated air, we use a preheated water, so that overall requirement of heat required to generate a steam will reduce. Secondly, we use a superheater. Now we will see for a numerical how the different points and what are the different aspects we have to consider for analyzing any boiler efficiency or any boiler plant. Suppose this is a boiler arrangement. It is now a representation, schematic representation. Now there is a grade where we have a furnace and we allow a fuel to get burned. So definitely we have to supply fuel. Imagine we are supplying coal. Okay, right now we are just imagining we are supplying coal, because there might be a gaseous fuel or liquid fuel, but coal is a very common. So we will consider that we are supplying coal to the furnace. Now, whatever be the exhaust gases evolved, no doubt when fuel get burned, so high temperature exhaust gases will evolve, and it is not possible that all exhaust gases will deliver its heat to the boiling water or boiler water. It is never possible. So some exhaust gases carrying heat along with them, and that exhaust gases first supply to economizer, to superheater, because that exhaust gas is having the highest temperature. So highest temperature is utilized to superheat the steam. After superheater, where steam is loses some heat, so after superheater, we supply exhaust gas to economizer, where we preheat water, and that preheated water is supplied to boiler. And after economizer, whatever be the heat remaining in the exhaust gas, we recover by using air preheater. We preheat air and supply to combustion, where fuel and air get burned and heat is evolved. So in short, whatever be the heat evolved, some part is utilized in generating steam in a boiler. Remaining part of heat carried by exhaust gas, those heat first recover by superheater to superheat steam. Then remaining heat is utilized by feed water in economizer to preheat feed water, and ultimately the heat is utilized by air, atmospheric air, to preheat it in air preheater, and remaining heat is exhausted into the atmosphere without recovering, without use. By notation, we can say that economizer, we are supplying room water temperature, that is, we said cold feed water. H, small h, stand for enthalpy of that water. F stand for fluid, and I stand for inlet. So HFI, that is enthalpy of fluid at inlet. Which fluid? So room temperature water. Hot feed water, after economizer, definitely exhaust gases preheat this water, so water temperature will increase. Water gains some heat, so definitely its enthalpy will increase. So the enthalpy of preheated water is noted as HFO. So H is enthalpy, F is fluid, and O is outlet of economizer. So economizer inlet having some enthalpy, after getting heat, enthalpy of water get increase, it is denoted by HFO. Next, cold atmospheric air. So cold, it doesn't mean it is at a lower temperature. Whatever be the atmospheric temperature air is there, that air, so it is denoted by temperature of air at intake or inlet to air preheater. When exhaust gas preheat it, so its temperature increase, temperature of air at outlet of air preheater. This temperature air is supplied to combustion. Now by using heat, steam is get generated. Now steam, we cannot say that steam is a dry or it is superheated. Might be it is a wet steam, that means it's still having some moisture. So wet steam having some enthalpy, that is H. So in actual, we can say in boiler shell, we supply heat so that our water which is having enthalpy HFO get increased to enthalpy H in conversion of water to steam. When this wet steam, generated steam, is supplied to superheater, exhaust gases, again it supply heat and it becomes superheated. Superheated, that means it is not having any sort of water moisture and it is increased temperature. Now imagine we have suppose 0 degree centigrade water and we are supplying heat. So what happened from 0 degree centigrade water? First water get heated up to 100. That means we are supplying sensible heat. So we recognize there is a rise in temperature. After 100 degree centigrade water, when we supply more heat, then water temperature will not increase. Its phase started changing. So 100 degree centigrade water to 100 degree centigrade steam generation is there. After that, if we provide a heat, so now steam which is at 100 degree centigrade, it gets superheated. Now steam temperature rising. So we get 110 degree centigrade steam, 120 degree centigrade steam. That means we get a superheated steam. So superheated steam, no doubt it having its own enthalpy, that is denoted by H of super, that is superheated steam. Exhaust gases temperature wise, so whatever be the exhaust gases removing from boiler, it is denoted by TG1. After superheater, its temperature get reduced because some heat is supplied to superheat steam, so its temperature reduced to TG2. After economizer, again its temperature get reduced and its temperature become TG3. And final, after air preheater, its final temperature will be TG4. And this temperature exhaust gases are actually enter into the atmosphere. So thermal emission will be there, but according to this temperature. If we are not using all these accessories, so our thermal emission will be according to TG1, which will be a more. Okay, so we are tackle thermal emission as well as we are recovering waste heat by using all these accessories. Now notation wise, MF. So remember, these are standard notation. In exam, directly it comes, MF is this much. MF is mass of fuel burn in kg per minute. Most commonly it is given in kg per minute, but if it is given in kg per second, so we have to consider that kg per second. Now MF, that is a mass of fuel. Mass of fuel, fuel might be a coal, liquid or gaseous, whatever be that. So MF is a mass of fuel. It is in kg per minute. Second notation, MA, mass of air supplied per kg of fuel. So remember, in boiler especially, mass of fuel is more important, and mass of air is the requirement of that fuel to get burned. So mass of air, most commonly it is given in per kg of fuel, in terms of per kg of fuel. Mass of air, it is directly not given kg per minute. It is given per kg of fuel. That means if I using mass of fuel 1 kg and mass of air required suppose 5 kg. So this 5 kg for burning 1 kg of fuel. So if I increase my fuel rate 2 kg, so my mass of air supplied will be double then. So 1 kg required 5 kg of air. So 2 kg of fuel required 10 kg of air. So mass of air is always dependent on how much fuel is supplied. So fuel always given in kg per minute or kg per time, and mass of air is always given in kg per kg of fuel. Next notation, mass of flue gases. How much gases are evolved? So mass of that hot gases. So mass of flue gases or hot gases per kg of fuel. It is also given in a unit of per kg of fuel. Next, mass of steam. So mass of steam is given in kg per minute, even though it can be given in kg per kg of fuel. That is also possible, but in most of the cases it is given in kg per minute. That means with respect to time. So rate is given. Then mass of moisture. Now here we can say mass of moisture, that is per kg of fuel. So moisture means water amount. How much amount of water is there which get converted into steam? That is called mass of moisture. Then temperature of atmospheric air at inlet to air preheater, so TAI. Temperature of hot air outlet from air preheater, that is TAO. Temperature of exhaust gases 1, that is denoted by flue exhaust gases temperature entering to superheater or removing from boiler. TG2 is temperature after superheater or entering to economizer. TG3, temperature of exhaust gases after economizer or entering to air preheater. And TG4 is the hot flue gases exist or removing from air preheater or entering to the atmosphere. Desaturation. So saturation temperature for water, we know that what is the saturation temperature. So it is 100 degrees centigrade. So when we heat water up to 100, after that we cannot increase the water temperature. After that your water get converted into steam. Same wise, steam having some saturated temperature. So suppose we have a steam, generated steam, and it having some moisture. So after generated steam, if we supply heat, so steam will not start directly increasing its temperature. Its quality get increase. That means suppose initially it having a 30% moisture. So if we add heat, supply heat to the steam, so its moisture gets reduced, vaporize. So after heating, we found that 20% of moisture is there. Again, supply of heat, 10% of moisture, then 5% of moisture. Likewise, when your steam having 0% of moisture, that means it reached to saturation temperature of steam, or that is vapor pressures. So T saturation. After T saturation, if you are going to add heat, so your steam start superheating. Now 105 degrees centigrade steam, 110 degrees centigrade steam. So superheating will be there. CP of air, specific heat of air, and basic unit kilojoule per kg Kelvin. CP of gas, that exhaust gases, so kilojoule per kg Kelvin. So most of the time CP of exhaust gases and CP of air, it is given in your numerical. CP of super, that is SUP, so it is a specific heat of superheated steam. HFI, enthalpy of feed water to economizer. HFO, enthalpy of feed water outlet from economizer or inlet to boiler. And H is the enthalpy of steam generated. And last, H super is the enthalpy of superheated steam after superheating. So these are the all notations we have to use. Now the last part, heat balance sheet. Once we know what are the parameters, so heat balance sheet, how to draw, how to calculate. So what is the heat balance sheet? Heat balance sheet represent an account of heat energy supplied in fuel burning and the breakup of heat energy utilized by the various component of the boiler plant. That means suppose I am burning 5 kg of coal. So 5 kg of coal after burning providing some amount of heat. So that much amount of heat is actually I supply to boiler plant. But whether every amount of heat utilized to generate a steam? No. Some amount is utilized for generating steam. Some amount of heat is utilized to preheat water in economizer. Some amount of heat is used in superheater to superheat the steam. Some amount of heat is used by air to preheat it. Some amount of heat exhausted into atmosphere along with the exhaust gases through chimney. So there are two parts: heat generation, how much amount of heat is generated, and how we utilize that generated heat in different aspects for generating steam, for superheating, for economizer, in air preheater, and what is the amount which is exhausted. The heat balance sheet is usually drawn either on the basis of kilojoule per minute or on the basis of kilojoule per kg of fuel burn or on percentage basis. So many times it is in numerical said that draw heat balance sheet on kilojoule per minute basis. So your all heat unit should be in kilojoule per minute. Many times it is asked that draw heat balance sheet on kilojoule per kg of fuel. So every calculation we have to convert into kg per kg of fuel, kilojoule per kg of fuel. Or many times it is asked to draw heat balance sheet on percentage basis. So every utilization part we have to convert into percentage basis. Now what we have to consider in heat balance sheet? So first is heat energy supplied by fuel. So when we burn a fuel, how much amount of heat is supplied? So it is always calculated as mass of fuel per minute multiplied by calorific value of fuel. So remember, fuel might be a coal, that is solid, might be a liquid LNG, or might be any gaseous fuel. So mass of fuel denoted by MF and its calorific value. So if we multiply this, so we get a total amount of heat evolved by burning of fuel, and that much amount we actually supplied. So that is heat energy supplied. Now MF into CV, this much amount of heat is we supply to the boiler plant. Now how it is utilized? So first part is heat utilized to generate steam. So some amount of heat is directly given to the boiler and boiler generating steam. So how much amount of heat actually utilized to generate a steam? So it is calculated as mass of steam generated per minute multiply by enthalpy of feed water to boiler. Remember, enthalpy of feed water to boiler, that means HFO. After economizer, how much is the enthalpy? And enthalpy of steam, that is H. So this is HFO. So after economizer, and this is enthalpy of steam generated. So mass of steam generated multiplied by difference of enthalpies. So no doubt, enthalpy of steam having higher value than enthalpy of your heat supply, water supply, and it is denoted by HFG. Why HFG? So H is the enthalpy, F for fluid, and G for gas. So whenever steam is generated, we are not sure that steam is 100% only steam. It don't have moisture. If there is only steam, we can say it is 100% steam. That means dry saturated steam. That time we denote as Hg, enthalpy of gas. But when it is a generated steam, so it having some moisture, that means some fluid, some water particles. So that is denoted as enthalpy of fluid and gas mixture. So Fg, fluid and gas mixture. It is in short, say, wet steam. Next, heat utilized in economizer to heat up the feed water. How much heat is utilized? So mass of steam generated per minute. Why again mass of steam generated per minute? So remember, in boiler, suppose ms, this much amount of mass of steam is generated. If this much amount of water get converted into steam, so same amount of water we have to feed to the boiler again. So if ms amount of heat steam is generated, so we have to provide ms amount of water to boiler. So how much water supply to boiler? So it is always equals to how much amount of steam is generated. So ms. So mass of steam generated per minute, that much mass of water we have to supply, multiply by enthalpy change of water now. So in economizer, what is the enthalpy change? So there is HFI and HFO. So HFI minus HFO. So HFI will be lesser than HFO. So we have to consider HFO minus HFI, highest minus lowest value. So mass of steam generated, that means amount of water we are supplying, and enthalpy change HFO minus HFI. So enthalpy of fluid outlet to economizer minus enthalpy of fluid inlet to economizer. Third head is heat utilized in steam superheating. For that, mass of steam generated. Now again mass of steam generated. Why? So whatever be the steam generated, that much amount per minute we are supplying to superheater. So suppose ms amount of steam is generated, this ms amount of steam is supplied directly to superheater where it gets superheated. And as ms amount of steam supplied to superheater, that much space is there in boiler, so we supplied ms amount of water to again boiler. So it is continued loop is there. So again, mass of steam generated per minute multiplied by enthalpy change. Now enthalpy change, so enthalpy of superheated steam minus enthalpy of generated steam. So our formula will be mass of steam multiplied by H super minus H generated steam. Fourth head, heat utilized in air preheater. So it is mass of air supplied per minute. Now remember, it is not mass of steam generated, because air supplied is not depend on steam generated. So mass of air supplied per minute. Now how to calculate mass of air supplied per minute? Because it is normally given in per kg of fuel. So we know that how much fuel is supplied. So from that, how much air is required per minute, we have to calculate that. So mass of air supplied per minute multiply by specific heat of air multiply by temperature change. So mCp delta T, that is a very common form. So mass of air supplied, So how we come to know how much amount of mass of air is supplied? So multiply by mass of fuel. So we get total mass of air supplied per minute. CPA, that means CP of air, specific heat of air, and change in temperature. To remove the negativity, we have to take higher minus lower. So TAO minus TAI. So we have to consider higher minus lower. So negativity will be removed out. So temperature will be higher minus lower. So MA multiply by MF into specific heat into temperature change. Fifth head is heat carried away by flue gases. So whatever be the remaining exhaust gases, it is exhausted into atmosphere. So how much heat is carried by that exhaust gases? So mass of air supplied per minute, because air, it is not get consumed. It will flow through all the process and exhausted through chimney. So mass of air supplied per minute multiplied by specific heat of flue gases. Even though we can say mass of air supplied, we can say mass of exhaust gases. Many times exhaust gases are there. So we can say mass of exhaust gas supplied per minute multiply by specific heat of flue gases multiply by temperature change. Now what is the temperature change? So temperature after air preheater and temperature of your atmospheric air, this much temperature difference having that exhaust gases, and that thermal emission is exhausted into atmosphere. So mass of gases multiply by mass of fuel. Now mass of exhaust gases will depend on mass of fuel. So product of mass of gas multiply by fuel. So we get a mass of exhaust gases per unit time multiply by Cp of gases, then temperature difference. So Tg4 minus Tai, this is atmospheric temperature. So this much amount of heat is exhausted into atmosphere. Now still we found there is unbalance. If we calculate, so we found there is unbalance. So there are many points where we can say this remaining amount is utilized. So one point is heat carried away by moisture by combustion. So some heat is utilized to remove the moisture during combustion. So mass of moisture per minute multiplied by saturation temperature of water minus temperature of preheated air plus enthalpy of steam at saturated temperature plus specific heat of superheated steam, because steam generated steam having a moisture when it gets superheated. So again that moisture gain this heat and get converted into steam. So this moisture, wherever the moisture content is there, heat is utilized to get converted into vapor. All these heat is called as heat carried away by moisture by combustion. So by notation, mass of moisture multiplied by mass of fuel multiplied by T saturation minus T air supply to boiler or air outlet temperature from air preheater plus HFG enthalpy of fluid and gas, that is wet steam, plus Cp of super heated steam, then temperature difference of Tg4 minus T saturation. And the last part, still there is some mismatch of your account of heat balance. Where it is mismatch? So some heat get radiated, some heat utilized to heat up your boiler parts, some heat convection is there, so some heat carried away by surrounding air flow. So these are not countable. So what we did, so we do a difference of total heat supplied minus all these 6 head of heat. So whatever be the difference is there, we said that that difference is an unaccounted heat. So that cover all everything heat losses. So heat loss by radiation, heat loss by convection, heat utilized by heating your metal parts and all. So all these are considered as unaccounted heat.